Okay, so in this lesson, we're going to continue talking about simplified rational expressions. This is going to be part two. And in part two, we're going to talk more about dividing out opposite factors. Now, when we did the previous one, remember, if you look at all the factors that we divided out, 3, 3, those were identical. X plus 11, those were identical. X minus 3, those were identical factors. 2x plus 1, 2x plus 1, identical factors. All right, so they were identical. Now, let's talk about what we mean by opposite factors. Okay, so in a previous course, you talked about something like this. The opposite of 8 is negative 8. So 8 and negative 8 are opposites. The opposite of negative, let's say 2/3, is a positive 2/3. Negative 2/3 and 2/3 are opposites. Okay, so okay, so now so those are opposites. So if I divide them, and we're going to use this idea in some of our problems, if I look at the quotient of those two numbers, the ones that are opposites, 8 divided by negative 8, I end up getting a negative 1. Or you could also say 8 divided by 8 is 1. Negative 8 divided by 8 is a negative 1. So you could also think of it as this, 1 divided by negative 1, or negative 1 divided by 1. It doesn't matter. But all those three things right here, negative 1, 1 divided by negative 1, negative 1 divided by 1, are all the same. So this idea we're going to use in some of our problems. Okay, now, for almost all students, finding the opposite of a real number is pretty easy. So if this is a negative 6, you'll say the opposite of negative 6 is 6. Okay? But the important thing here for us, what we're going to do here, is that when I divide two numbers that are opposites, or two factors that are opposites, I end up with a negative 1 as the quotient. Or 1 divided by negative 1, or negative 1 divided by 1. Okay, that's going to be important. Okay, so let's kind of review some more stuff. The opposite of x is negative x. The opposite of x is negative x. So again, if I look at the quotient, x divided by negative x, I get a negative 1. Because x divided by x is 1, negative x divided by x is a negative 1. And 1 divided by negative 1 is a negative 1. The opposite of x minus 2, now we're looking at a binomial. The opposite of x minus 2. So if you remember, the opposite of just one thing, it's just changing the sign. So the opposite of 8 is negative 8. The opposite of negative 2/3 is a positive 2/3. The opposite of x is a negative x. So right here, look at each term individually. That's the best thing to do. So the opposite of x minus 2 is this. Is the opposite of x is a negative x. The opposite of a negative 2 is a positive 2. So that's the opposite of x minus 2. So the opposite of x minus 2 is a negative x plus 2. Now I want you to think about something. I want you to realize this also, because you're going to see this too. I can rewrite a negative x plus 2 as 2 minus x. It is very important that you see that those two things are the same thing. A negative x plus 2 is 2 minus x. 2 minus x. All right? So the opposite of 3x plus 5, the opposite of 3x plus 5 is, the opposite of 3x is a negative 3x. The opposite of a positive 5 is a negative 5. And again, you can rewrite this as negative 5 minus 3x. All right, so just make sure you understand that those two things are the same exact thing. They're just written in a different order. All right, now let's see one more. The opposite of negative 5x minus, we'll say plus 2. Negative 5x plus 2. So the opposite of a negative 5x plus 2 is, the opposite of negative 5x is a 5x. The opposite of a positive 2 is a negative 2. Or if you want to, you can rewrite it as negative 2 plus 5x. So they're the same thing. All right. And again, if you look at their quotient, I want you to understand this. If you say negative 5x plus 2 divided by 5x minus 2, based on what we talked about right here, remember those are opposites. This is the opposite of that. So whenever you divide two things that are opposites, this is going to end up being a negative 1. Their quotient, the quotient is a negative 1. All right? Okay, so let's look at some problems now. Now that we kind of did a review here, let's look at some problems. Okay, so let's simplify each of the following. Okay, number 1. Suppose we had x minus 4 divided by 4 minus x. X minus 4 divided by 4 minus x. All right, now, don't think that those are exactly the same thing, because they're not. This is a positive x, whereas this is a negative x. This is a negative 4, whereas this is a positive 4. So don't say the answer is 1. All right? That's not true. The answer here, the quotient is not 1. Okay. Now, I want you to think about this. This is where you're going to have to start thinking about, well, are they opposites? Are they opposites? So x minus 4 divided by 4 minus x, those are opposites. Remember, we talked about that. So those are opposites. So that means that if I divide two things that are opposite of each other and I reduce them, like I did here, the numerator is 1, the denominator is negative 1, or the numerator is negative 1 or the denominator is 1, or altogether the quotient is just negative 1. Okay? So right here, you can think the same thing as well. Since they're opposites, these are opposites, x minus 4 and 4 minus x, if I look at the quotient, that quotient automatically is a negative 1. That's what I need you to think of. That's a negative 1. All right. Now, here's what I want you to think of also. So most students, though, if they see that these are opposites and it's just a binomial and a binomial, they say negative 1. But I want you to think about this. Okay. So if those are opposites, I'm going to leave the numerator as x minus 4. All right. And I'm going to factor out from the denominator, I'm going to factor out a negative 1 from the denominator. Okay. So I want you to see what's going to happen. If I factor out a negative 1 from the denominator, negative 1 times a negative 4, negative 1 times a negative 4 is a positive 4. Negative 1 times a positive x is a negative x. All right, now remember what we talked about a while ago. I wanted you to remember, I want you to understand that negative x plus 2 is the same as 2 minus x. Negative 3x minus 5 is the same as negative 5 minus 3x. 5x minus 2 is the same as negative 2 plus 5x. Okay? So negative 4 plus x, right here, so I just rewrote x minus 4, negative 1. Negative 4 plus x is the same as x minus 4. And then using the idea from the previous lesson, see how the x minus 4s are identical? So I can divide these out. And notice I got 1 divided by negative 1, which is just a negative 1. And that's what we got here. All right. So if you could recognize right away that these two factors are opposites, then their quotient is just a negative 1. Now the long way, and you also need to understand, well, why is that quotient a negative 1? Well, that's because from one of the factors, I can factor out a negative 1. And when I rewrite it, it's going to look exactly like the other factor. And then I can just divide those out, 1 divided by 1, and I get 1 in the numerator. A negative 1 times 1 is a negative 1. And 1 divided by negative 1 is just a negative 1. Okay? All right, so let's look at this one. All right, suppose we had negative x minus 4 divided by 4 plus x. Negative x minus 4 divided by 4 plus x. Okay, I want you to notice that they're not identical, definitely, so that you know that the numerator does not look exactly like the denominator. But I want you to think about, are they opposites though? So the way to do that is this. The opposite of negative x is a positive x. That's what we got down here. The opposite of negative 4 is a positive 4. That's what we got right here. So yes, those are opposites. So right off the bat, since they're opposites, you can say that that quotient is a negative 1. And you're done. If two things divided by each other are opposites, then the quotient's a negative 1. But let's go through this process again just to show you. So I'm going to go ahead this time and factor out a negative 1 from the numerator. So if I factor out a negative 1 from the numerator, I get negative 1 times negative 1 right here. Negative 1 times times an x, a positive x, is a negative x. Negative 1 times a positive 4 is a negative 4. And my denominator is just 4 plus x. Right? Now I want you to recognize that x plus 4 is the same as 4 plus x. So right off the bat, I can reduce those. When I divide them out, I'm left one in their places. Negative 1 times 1 is a negative 1. 1 down here. Negative 1 divided by negative 1 is a negative 1. And you're done. All right? Okay, let's look at this one. Suppose we had, let's see. All right, suppose we had b squared minus b divided by 4 minus 4b. So b squared minus b divided by 4 minus 4b. Okay, so from the numerator, first of all, the GCF of the numerator is b, so I can factor out a b, and I'm left with b times b is b squared minus 1, because b times a negative 1 is a negative b. In the denominator, though, I get I can factor out a 4, so I get 4 times 1. 4 times 1 is 4 minus b, because 4 times a negative b is a negative 4b. Okay? All right, so look at your factor, see if you can reduce. There's a b here, a factor, but there's no b as a factor down here. There's a b minus 1 as a factor up here. There is no b minus 1 that looks exactly down here, but we know that these are opposites. The opposite of b minus 1 is 1 minus b, because look, the opposite of b is negative b, the opposite of negative 1 is a positive 1. So they're opposites. So right off the bat, if you want to, and let's use this idea here. Remember where we said that if I have two things that are opposites of each other, like right here, I can reduce those. 8 divided by 8 is 1. Negative 8 divided by negative 8 divided by 8 is a negative 1. So I get 1 over negative 1. All right. Or I could have said negative 1 divided by 1. All right. It doesn't matter. So what you to think about is this. See how these are opposites? So there are several ways you can go about this. All right, so I'm going to kind of do it the several ways. So right off the bat, I know that if two things are opposites of each other, I get negative 1. So which means this right here, when I look at the quotient, that's just a negative 1. All right, that's a negative 1. Now be careful. Don't think of this as b minus 1, because remember this was b times b minus 1. So this is b times a negative 1, which is a negative b, and this is 4 right here. So I get b over negative 4 as the answer. All right, so that's one way to approach this. So I'm going to go ahead and rewrite the original this again. So that's b times b minus 1 divided by 4 times 1 minus b. All right, now the other approach is this. All right, well, if they're opposites and to divide them out, and this is where this comes into play now, and to divide those out, then the numerator is 1, the denominator is negative 1, or the numerator can be negative 1, the denominator is 1, because I know that 1 divided by negative 1, or negative 1 divided by 1, is a negative 1. So which means this, I can make this right here a negative 1, and this right here a positive 1. Because remember, if I have two factors that are opposites of each other, if I have two factors that are opposites of each other, the numerator is 1, the denominator is -1, or the numerator is -1, the denominator is a positive 1. Because remember, this is the same thing as saying -8 divided by 8. 8 divided by -8, same thing as -8 divided by 8. So that's -1 divided by 1. All right? Okay, so b times a -1 is a negative b. 4 times 1 is 4, which is what we got here. All right? The other way to approach this is this. So you got to think about this also. b times b minus 1 divided by 4 times 1 minus b. All right. So instead of putting the when I reduce these, instead of putting -1 in the numerator, 1 in the denominator, let's do 1 in the numerator, a -1 in the denominator. All right. See what happens. b times 1 is b. 4 times a -1 is a -4b. And that's fine. That's correct because remember, b divided by -4 can be written several ways. It can be written as negative b over 4, or it can be written as negative the fraction b over 4, like this. You can have the negative out in front. Okay, so either one of these are all correct answers. Okay, all right, so it's number 3. Let's look at the next one. All right, suppose we had 25 minus z squared divided by z squared minus 10z plus 25. So 25 minus z squared divided by z squared minus 10z plus 25. All right, the numerator I can factor. That's the difference of two squares. So I'm going to get 5 minus z times 5 plus z. That's the numerator. The denominator, when I factor this, the g self here is 1, so I'm going to go ahead and factor those two binomials. So that's z, that's z. For 25, I need 5 and 5. The last sign is positive, so it means these signs here are the same. They're both going to be this middle sign, so they're both going to be negative. And so that's where I'm at. All right? Now, I'm going to skip this one for right now. See this 5 plus z? Is there 5 plus z down here occurring as a factor? The answer is no. All right, see this 5 minus z? Is there 5 minus z occurring as a factor down here? Does it exactly look like a factor down there? Is there something identical to it? The answer is no. But we know that 5 minus z and z minus 5, either one of those, doesn't matter, are opposites. They're opposites. 5 minus z and z minus 5 are opposites. So that means this. If I look at their quotient, I get -1. If I look at the quotient, I get -1. And that goes from our discussion when we talked about all of this right here. So if the quotient is -1, then that means that when I reduce these out, this could be -1 and this could be 1. All right, because remember their quotient is -1. -1 divided by 1 is a -1. All right, now here's what you can do. It doesn't matter how you write it. So you can say this. You can say, well, that's going to equal -1 times 5 plus z over 1 times z minus 5, which is z minus 5. So that's fine. You can leave your answer like this. There's nothing wrong with that. Or if you distribute, you can distribute this. -1 times 5 is -5. -1 times a positive z is a negative z over z minus 5. Either one of those is fine. Okay. Now you could also done this as well. Okay, so listen to what else you could have done. So see how I put -1? I crossed the line through this, so I divided these out, and so this would be -1. This would be +1. You could have also done this. So let me go back and do this. So remember, anything boxed is a correct answer. So 5 minus z, 5 plus z, divided by z minus 5, z minus 5. Now when I reduced these two, I could have reduced these two as well. It did not matter. All right, but I'm just using the first one. All right, so instead of saying -1 divided by 1, I'm going to say this time 1 divided by -1. All right, so see what we get there. So 1 times 5 plus z is 5 plus z over, okay, and so I can say -1 times z minus 5. So that'll be an answer. So anything boxed is a correct answer. They're all equivalent. Or if I distribute, I would have 5 plus z as a numerator. Now if I distribute the negative 1, I get negative 1 times z is a negative z. And then negative 1 times a positive 5 is a, I'm sorry, negative 1 times negative 5 is a positive 5. So either one of those is fine. Okay? All right, number 5. This was actually, yeah, number 5. So number 5, we have this. We have, let's see. Okay, we have 49 minus y squared divided by y minus 7. So 49 minus y squared divided by y minus 7. Okay, so you need to recognize that the numerator is the difference of two squares. And so I can factor this as 7 minus y times 7 plus y, just like this, all over the denominator, which is y minus 7. All right, now, the numerator and the denominator, you don't see anything that's identical like you did in the previous lesson. Nothing's identical. So over here, you had things that were identical. X minus 3, 2x plus 1, 2x plus 1. You don't see that here. But, remember, well, I want you to think of the word opposites now. But, this right here, 7 minus y and y minus 7 are opposites. They're opposites. So that means that when I reduce them like this is a negative 1, this is a positive 1. Or I could say positive 1 over negative 1. But I'm just put the negative 1 up here. And so your answer then would be negative 1 times 7 plus y over 1, but that's just negative 1 times 7 plus 5. Okay? Or if you distribute, you get negative 7 minus y. It does not matter. Okay, so that was number 5. All right, let's look at this one. All right, number 6. Let's suppose we had, let's suppose we had 3 minus x in the numerator divided by x cubed minus 27. So 3 minus x divided by x cubed minus 27. All right, so I can't factor the numerator, but I can factor the denominator because that's the difference of two cubes. So let's just kind of figure out how to factor the, that's supposed to be an x, how to factor x cubed minus 27. So it's the difference of two cubes, remember, because I can fill in these parentheses. X times itself 3 times is x cubed, 3 times itself 3 times is 27. So there's my first, there's my last, and when I factor this, remember it's f minus l times f squared plus fl plus L squared. So that's how you factor this. And so when I factor this x cubed minus 27, I'm going to get x minus 3. Remember f, I got to square f, so that's x times x is x squared, plus, then I multiply the f and the L together, so that's going to be x times 3 is 3x, and then plus L squared, so I take L and I multiply by itself, so 3 times 3 is 9. So there's your denominator, so I'm going to get 3 minus x divided by x minus 3 times x squared plus 3x plus 9. All right, don't forget to extend this division symbol. Extend it all the way. All right, so there are no identical factors, but you do know that these right here are opposites. 3 minus x and x minus 3 are opposites. The opposite of 3 is a negative 3. The opposite of negative x is x. So that means that when I reduce those, I can reduce those. So when I reduce those, I'm going to put the negative 1 up here and a positive 1 down there. And so I get negative 1 divided by x squared plus 3x plus 9. All right, now another way you can write this, just like we mentioned, let me see if I can find it, just like we mentioned here. So if I have b divided by negative 4, or negative b divided by 4, I can also write it as a negative out in front, so negative b over 4. So in other words, what I'm trying to get you to see is that I can write this right here as negative, and then the fraction 1 divided by x squared plus 3x plus 9. All right, so either way is fine. Okay, so that's going to take care of part 2 of this.